Hello, and welcome to a Nautical Institute webinar, a really exciting Nautical Institute webinar. I'm David Petraco. I'm with the Nautical Institute staff in London, and I'm being joined by Jaquelyn Burton and Margareta Lützhöft, both actually in Norway at the moment, I believe. So thank you for coming, and I will introduce them in a little bit more context soon. So the Nautical Institute, just to remind you, we are an international professional body, and our main role is to help our members learn. We do that primarily by sharing ideas amongst ourselves. And the reason that sharing ideas is so important is the more you learn, the more you share ideas, the better decisions you make. And that's what it's all about. At the end of the day, we want to help people make better decisions. Now, this is ideal, absolutely ideal for this issue of this webinar, because we are going to be talking about how navigators use information to make good decisions. And it is about the navigators, and I'll explain that in a little bit more detail, but it's trying to give people the right information at the right time so that they can make excellent decisions. And that's what this is all going to be about. And just to let you know, well, I'll introduce the Ocean Project. So the Ocean Project is a EU-funded project, except for us in the UK, and we're funded by the UKRI. I won't get into the details of why. But it is about operator-centered enhancement of navigational awareness. And this is about how can we be sure that in the future, when things get more complex, that we have more information, that information is presented in a way that makes better that makes better sense, so that we can make better decisions. Now, I'm just going to share with you a short video, just 4 minutes, about that Ocean Project, just to help put it in context, so that you'll be able to participate more fully. So here we go.
It is easy to forget that at any given moment there are hundreds of thousands of vessels crisscrossing our oceans. The numbers are just massive. A staggering amount of vessels, people, and ports are involved. In spite of its great complexity and the huge number of vessels, the industry has an excellent safety record. That's because seafarers are incredibly capable and rigorously trained. But accidents do happen. Accidents happen not because seafarers are not good at what they do, but because, for a plethora of underlying reasons, they either don't realise there's a risk, or they can't avoid it. Ships occasionally collide with other ships, with fixed structures, or run aground. Containers might fall off ships and remain floating, causing risk. And unfortunately, vessels have hit whales, particularly near migration routes. But what if navigational passages could be made even safer by greatly improving the situational awareness of those handling the ships? That is precisely why the European Union and the United Kingdom have decided to fund the Ocean Project. We believe that successful watchstanding happens when humans, technology, and organisational matters like training, procedures, and rules and regulations work in unison. Our aim is to support mariners through equipment that is designed to more directly support human needs. This will increase their capabilities by improving their situational awareness and evasive manoeuvring capacity, rather than by increasing the autonomy of the vessel itself. Open, voluntary, and free sharing of information is at the core of Ocean, because we want to enable the seafaring community to help each other to make even better decisions. This is how it'll work. Say there's a hazard, maybe a floating container or a pod of whales crossing a waterway. The hazard will be spotted by either a person who reports it via our ocean reporting app, or it could be detected by a satellite, seasonal forecasts for marine mammal migrations, or even hydrophones listening for cetaceans. The information would be almost instantly transmitted to a database on shore, which would communicate that to all types of vessels using tools that already exist on their bridges. The Ocean Project will also model the drifting of floating hazards and the movement of marine mammals, so the reporting will happen in near real time, which is crucial to build trust and compel seafarers to take immediate action. Parallel to this, the Ocean Project will develop the Ocean 4D Situation Awareness Display, which will provide an integrated, designed for the purpose, uncluttered and focused presentation of near-field threats and navigational hindrances. The Ocean Project will suggest the creation of a European navigational hazard infrastructure to collect, process and distribute data relating to the presence of marine mammals, floating containers, and other dynamic navigation hazards. Ocean's Evasive Maneuvering Agent, or EMA, will be an improved maneuvering tool working in tandem with existing ship systems, continuously assessing navigational safety. These tools will mostly be open source solutions, free of charge and subject to voluntary adoption. This project is pulling together a wide community of stakeholders to create powerful and effective solutions. Ocean might not single-handedly solve the challenges that seafarers face daily, but it will definitely be a valuable step towards the solution. Keep Ocean on your radar and subscribe to our mailing list.
Right, so that is what the Ocean Project is about, and you will see that a big part of that is to create a display that helps people make better decisions. And Jackie here is going to be designing that. She is a mariner and she wants to hear from other mariners. She really, this is the whole project is about human-centered design. It's about asking the navigators how they want their displays to work. So it's really important that you participate, and we'll tell you, each and every one of you will have a chance to be involved in the design and the testing of this product. So stay tuned till the end and we'll let you know how to get involved with that. Now, this is a very interactive webinar. Your cameras and your microphones will not work, but we absolutely want you to participate and give us your comments. Everything will be recorded, so if for some reason we don't get to your question live on air, it will be, we will read it and learn from it. So there will be a number of polls to engage you, and so that we learn a little bit more about you. But the first poll we're going to do right now, and it is going to ask you, have you ever been asked your opinion about a navigation display? Now, Jackie, what are the thoughts around this?
Yeah, so what we found is a limited amount of engagement between us as manufacturers and the navigation community and the maritime community as a whole, and also individual feedback in particular. We might have some people that say work for us, or some people that work in the offices of different shipping companies that may have been navigators at one point, like myself, but who are not actively navigating. And what happens when you're making design decisions is that sometimes you forget all of those little annoyances that you had as a navigator, that navigators feel every day while they're working and while they're doing passage planning and while they're making traffic decisions. And those annoyances aren't taken back into the design process a lot of the time, so the feedback isn't active.
Okay, Jackie, so you can see from the feedback, 78% say no, but a wonderful 22% have, and that's really good. That navigators have been asked, but we need to do better, and that's exactly what we're going to do here. So I can guarantee you that after this webinar, you will never be able to say know again, because we will be asking you of your feedback on navigation displays. So just to carry on, there will be a short survey at the end of this webinar, including an opportunity to be part of this project and to do some of the design and testing with us. There will be a certificate. There'll be an email probably 2 hours after the webinar finishes, and you'll get a certificate, those of you who have attended, with your name for CPD purposes. This is being recorded, and that recording will be put up on our YouTube channel probably by the end of the week, so you can view that. It'll also, of course, be on the Ocean Project website. And you are not alone. These figures are a little bit low. There are more than that. So when you do write in, if you keep your questions fairly succinct, we'll try to get as many as possible. So the presenters today are going to be Margareta, Erik, and Jaquelyn. Unfortunately, Captain Lynch, of course, we needed a seafarer, and he's in the project, and he was supposed to be here. But like seafarers, captains sometimes get distracted and things come up. So he is not going to be here today, but he is working with the project, and we're grateful for that. So we're going to have 3 presentations. Margareta is going to talk about what goes wrong if you don't get it right. Erik is going to talk about why it's so important to involve users. And then Jackie's going to talk about what we're doing in the Ocean Project, what she's doing on designing a new concept and asking you to get involved with that. So Margareta, Dr. Captain Margareta, Fellow of the Nautical Institute. I don't know how to put all that together. Obviously, she used to be a seafarer. She now has a PhD in human-machine interaction, and she is a professor with the Western Norway University of Applied Science, otherwise known as HVL. So Margareta, I'm going to give you the con, and over to you.
Thank you, David. Okay, I'm hoping you can see the presentation. Yes. Thank you very much. Thank you, David. It's really good to be here. We've been working on this endeavor for many years now, trying to get some more seafarers involved. So this is a really nice occasion to keep building on that. And I will speak a little bit about awareness and decisions, what we've learned so far in the project about what people do on ships. And the first thing is we looked into a special presentation, a report made by EMSA, which was a 10-year review of especially and only navigation accidents, and they found over 8,000 occurrences, whereof then they decided 570 something navigation accidents. 447 of them involved some kind of human action, and you'll notice they're not using the word human error. Almost half of them were related to observation, which you can see on the left. There is the first part of becoming aware. You observe something, you interpret it, and then you make a plan and an action. Those 227 observations were 130 overlooked cues and 95 incorrect or partial interpretations of this observation. And that's really interesting, because that means that almost 60% of these incidents that were related to observation were actually happening before you become aware of something. So it's not about presenting perhaps the best information, it's about making people aware that they need to look for information or find information. And when we started this project, we had a hypothesis already of what causes accidents, and of course we all know today that they are a result of a chain of events, not only one or few human errors, as they sometimes call it. We'd like to call it human variability. which could often trigger one of these chains of events, but it's definitely not the only factor. And what we already knew going in, or thought we knew, was that there were many factors such as standards and professional culture that's not fitting, organizational and operational drivers and pressures. Training might be improper or insufficient. The information that we provide is maybe not correct, timely, or relevant. Technology and technology design could be inadequate. All of this, of course, could lead to lack of situation awareness and sometimes also a poor planning and execution of maneuvers. But what we found in the looking into accident reports and also interviewing accident investigators, because a lot of the reports we were looking at didn't tell us enough about human behavior. Work and living conditions can lead to fatigue, depression, and low motivation, and this also, of course, has an impact on the professional culture and our situation awareness. Seafarers trying to balance conflicting pressures and procedures, and more time is used for administrative work. ICT, information and communication technology, is strongly emerging as an underestimated and under-researched factor. And we find that technology helps and hinders simultaneously, especially complex systems. They project trustworthiness and they hide weaknesses. It's not easy to see what the machine and the technology is doing. And alarms still, unfortunately, is a special case of both a barrier and a nuisance, because of course it gives us valuable information, but it usually also disturbs your concentration. Moving on then, how do we make decisions once we have been made aware of something? There are two main streams in this decision making. One is what we could call normative, as you should be doing it. It assumes that there is an unlimited amount of data or information. You have all the time in the world and you can evaluate several plans and outcomes. And what I like to call this is what you do that maybe once or twice in a lifetime. It's when you choose your university or when you decide to buy a house, a large life decision, you might sit down and go through all the parameters and values. But what most often happens is what we call descriptive or naturalistic decision making, in which a decision maker is usually an expert, as are seafarers. They use the situation assessment, and it's instead of having this unlimited data, it's recognition prime. They decide, they see a situation and they interpret, have I seen something like this before? They generate a good course of action, and they use a mental simulation to evaluate, is this course of action going to work in this situation? So it's based on experience and expertise. And these situations in which we use that kind of decision making are characterized by a long list of factors. For instance, ill-structured problems, incomplete, ambiguous, changing information, shifting, ill-defined and competing goals, a context that's characterized by multi-event feedback loops. And you might see already that this is very much like many of the situations we experience at sea. Time constraints, high stakes, many participants, and the need to balance choices and goals and norms. And you can recognize already also some of the underlying factors of the accidents I mentioned just now. So if we want to support the decision making, what we're trying to do in the Ocean project is using a naturalistic or descriptive decision-making model of human behavior is preferable to this normative one, where we assume that we can train people to act as they should, quote unquote. The performance factors in this case include knowledge of the task, knowledge and experience at sea, and this can be taught, trained and supported by technologies and procedures. And if you really design a procedure well, it's essentially encapsulated experience. And if we support assessment of the situation, we have made and provided a shortcut to good decision making. And to do this, we must help the seafarers sort and prioritize, considering what and how much information to provide, as well as how to represent this information and where. Because when experts choose an option, they choose one which is good enough, and it's sometimes called satisficing. And we need to provide some information that has been prepared before a situation arises, and that's based on a seafarer experience. And thank you for your time. And in a few moments, I know both Erik and Jaquelyn will be telling you more about how we're planning to do this.
Right. Margareta, I've known for many years, and she's put so much effort into understanding how humans make decisions, and it's a great challenge, of course, because things are moving very rapidly. So we can't necessarily just solve the problem for today. We need to look forward, and that's what we're doing with the Ocean Project, is actually looking forward and trying to figure out we're going to keep making good decisions, but into the future where we're going to have a lot more information, and we're able to have more information. So that's a good thing. The next speaker is Dr. Erik Petersen, also a associate fellow of the Nautical Institute, and unfortunately he does not have a good enough signal to participate, so he's pre-recorded his presentation, but he is a naval architect by initial education, but he has gone on to do various things in the electronic world, not least with SAM Electronics, where he was the product owner of navigational as well as head of strategy and portfolio management. He is now a senior researcher at the Western University of Applied Science, the HBL, and he is the director of the Ocean Project. So I'm just going to bring up his presentation.
Hello, my name is Erik Petersen and I'm the project coordinator of the Ocean Project. First and foremost, I would like to thank David and the Nautical Institute for arranging this webinar and asking me to contribute. About this session, you have now seen the project video and you have heard Margareta speaking about situation awareness and decision making. Improving both are very high on the Ocean Project list. Our ambition is to provide knowledge and tools that, in addition to supporting better situation awareness, which in turn is leading to better decision making, the project will also have an impact on future maritime usability and reliability. Let me dive into usability in this short presentation. Start with highlighting that usability is an objective. I will get back to the formal definition, but usability is about making things suitable for human use. Like on the slide, making things, in this case shoes, fit the person that are wearing them. This goes for all the things around us, so that we as humans can spend our energy on the job to be done rather than making our tools work the way we want them to work. I'm sure all of us have things around us that we find difficult to use, and especially perhaps for software, where we struggle to find the right settings and where the tool keeps surprising us, making us spending more mental energy than reasonable to make progress on the task we're concerned with. Usability in this case will be low, but can be improved through design, but let's look at the definition first. There's two definitions of usability, but they mean the same. Only the formal definition is more complete. The ISO 9241-11 definition is worthwhile to think a bit about, since it mentions users in a particular context, striving to achieve particular goals with effectiveness, efficiency, and satisfaction. In maritime, an example of good usability could be the watchkeeper on the bridge, striving to conduct safe navigation, using devices which gives her or him all the information needed for that purpose in a good manner, and so that she or he is expending only a reasonable amount of mental energy. One could believe that all navigation devices were designed with this in mind, but that is not necessarily so. Human data pieces of bridge equipment, radar, ECDIS, autopilots, echo sounders, etc. are regulated by the IMO through what is called performance standards. These in turn are made operational by the IEC device test standards, which is what the manufacturers are being measured against. You cannot sell and fit this kind of equipment to ships unless they have passed all the tests. And yes, the test standards contain several usability criteria or heuristics, which must be fulfilled to get type approval. In the present case, let's have a short look at each of the 6 rules of thumb. Consistency is a question of behavior and underlying operational principles and concepts being equal all across an application or applications. This is not simply a question of layout, but also covers the way the user think about the problem and how it should be solved. Presentation of information relative to its importance, the importance to the user that is. Note that this depends on the context and the problem the user is attempting to solve. Logical grouping is interesting because here it is a question of logic to the user and not to the designer or to anybody else. How does the user think and what appears to be logic relative to that thinking? Clarity of language is a question of knowing the terminology used in the domain and sticking to it consistently. Here comes consistency again. What expressions are the users using? And does that depend on who they are, how old they are, where their cradle stood in the world? Readability is mostly a question of font size and font types, but also reading distance. How do you know your layout? How do you know the instruments? Of course, you need to state a nominal viewing distance in your documentation, but is that observed by the naval architects designing the bridge? Finally, intuitiveness is not a simple issue. It involves often unconscious and experiential knowledge, and it is a reflection of other things users have encountered before. So how do you know that if you're the designer? This being said, all of these principles are really good principles. When we have good principles in the test standards, there are unfortunately bots, several actually. One bot is that the usability heuristics, some of the important usability heuristics are missing from that list. It's also so that there are no formal requirements to develop for usability contained in the performance standards or in the test standards. Usability test methods, where they are required, are not universally well suited for the purpose. And the number and skills of the testers is very important, but these are largely undefined and do not require formal usability skills. Finally, and what I believe is the most important, is that it is not required to have seafarers involved in the design and test of bridge equipment. Unless something happens, there is little hope for changes to the better when usability is concerned. Happily, however, the research in the Ocean project indicates that there is a growing understanding that simply fulfilling a series of test standards not necessarily provides the level of usability desired by the end users. The quotes on this slide are from professionals in the equipment manufacturing industry and demonstrates both insight that some see that they have been designing and producing systems that fall short of user expectations, and then to start wondering about what can be done about it. So it becomes rather a question of how than why. How, this is also a subject that the Ocean project is looking into, and where we continuously share our results. On the Ocean website, for instance, you will find documents addressing what principles designed for improved situation awareness should observe, but also which design elements we believe could be used successfully. This is only the first step. The Ocean partners will be working with each other in the coming period to help improve both the methods to design for usability, as well as to practice them in an industrial setting. The presentation Jaquelyn will make just following this is about novel bridge displays and how we are attempting to design these to provide better improved situation awareness. In other words, with better usability than what is typically the norm. I would like to zoom in on a series of principles and activities that together describes what is called human-centered design. It's a powerful way of designing for usability. And you can see from the figure, it starts with understanding that there is a need for human factors and human-centered design at all. Then it's very much about understanding the context of use. It is to specify the user and organizational requirements. It is to produce design solutions, and it is to evaluate designs against requirements. And this is an iterative process, so you keep going around in this figure until you actually meet the requirements that you set out from the beginning. We are working with each of these steps And this is where you come in. Seafarers are to be involved. As you can see on the figure, seafarers should be in the design team to provide the context of use directly to designers. And I'm sure that Jaquelyn will mention that in her presentation when it comes in a little while. We are also obsessed with testing with users. We believe this is hugely important to get an understanding at an early stage of designs whether they would fit the bill required by the end users. And you can see that testing and testing and testing is really the centerpiece of the figure. And we intend to go around this circle in a number of iterations until we are getting it right and until we can provide advice to other manufacturers about how to apply this method. Me to the end of my presentation and summing up where the seafarers can help the ocean project. A help which eventually, if all goes well, will be self-help. The benefits gradually becoming manifest in equipment which is more usable, provides better situation awareness and gives greater user satisfaction. So thank you. The reason this is being recorded, by the way, is that I'm on the move this morning. But you are very welcome to ask questions and I hope my colleagues can answer them. Other than that, I'm expecting to be able to listen into the webinar and will be online, hopefully, so you can put questions directly to me if you should have any. So thank you very much. Thank you again to the Nautical Institute, to David Petrego for arranging this, and enjoy the meeting.
Right. Thank you for that, Erik. Hopefully you're listening in. I do understand that some people, for some reason, the technology did not work and you didn't see the whole video. I'm sorry about that. We'll look into what went wrong. But the whole thing is being recorded. That recording will be made available on our YouTube and on the Ocean Project website, so that you will be able to watch it again. But I do apologize for the trouble. So I now would like to introduce Captain Jaquelyn Burton. Jackie has been a huge contributor to the Nautical Institute over the years, helping us understand the nature of technology and how to use it best. Jackie is one of those seafarers who actually did not like some of the designs that she was seeing and has actually done something about it. She's joined Kongsberg as the lead of the creative design, and she is very determined to develop systems that are user-friendly and do help us go into the future with better tools. Jackie is going to share a little bit of information about what she's doing in the Ocean Project, but most of all, why she needs a very broad base of mariners' feedback to help her design systems that are suitable to most people. So Jackie, on that basis, I will hand over to you. I will just say that one of the things that Jackie's done for the Nautical Institute is she's written an article about a digital shipmate. And that article is in your handout section. So if you'd like to download that article so that you can read it in full, please do. Other than that, Jackie, over to you.
Yeah, so like David said, I wrote an article a while ago in Seaways with John Owen, where we had been discussing in the Automation and Technical Advisory Group all the trouble with technology and how we introduce it to mariners and to the maritime community. And what I really wanted to bring out in this webinar, besides the fact that mariners need to give input into the technology to actually make it better and more useful for themselves, is that everything around you that's artificial has been designed by someone, and they've made trade-off choices in that design. So everything from a cup to the chair to a table to the little switches that you have on the bridge to buttons to thoughts of where things are on your screens, including this webinar software that we're using, how you turn on and off your microphone, how you turn on and off your camera. each one of those things someone has thought about in some way. And when we talk about usability, like Erik had talked about, it's only usable in a certain context by a certain person. So when you're looking at designing ship systems, we have to look at not just one mariner, but many, many, many mariners to try to find out what's the best way for us to make this usable by them. So I want you to think about design as not how pretty it is, but actually how it's constructed and how you interact with that. So there's both the human-centered design, and parts of that are also experience design. So like user experience design or customer experience design you might have heard about. And when you're looking at designing the experience, it's not just how you can physically use the system, but also how you as a user feel about the system, what assumptions you might make about the system, and trying to create a holistic experience about how you're using a system. So it's not just the technology that is technically able to give you information, but also how that information is given to you and in what context and in what ways. And there's been a lot of challenges on bridge design in particular. Let me see about the slides. There we go. Yeah. About the choices made in actually designing these slides. So this is one of the bridges that Kongsberg's delivered. And most of your bridges don't look like this. I would say that very few bridges actually look like this, where they've been designed for that particular use case for those particular users, where one supplier is supplying almost every piece of equipment. And when we have the kind of control to say that we're delivering the whole picture, then we have a lot of design choices as options that we can't normally make. Options like how things are displayed on which screen, in which distance from the operator itself. Most of your bridges look something like this. So this was a bridge that I worked on. I think I took this picture back in like 2015, 2016. And on this bridge, you have a lot of buttons, you have a lot of different control options, control devices, and many of it is delivered by many different parties. So it's not that it was designed as a whole workspace context where you as a seafarer have everything that you need within reach to meet your goals, but more in the context of it needs to have these features available. So it needs to have this list of equipment, it needs to have this list of options. All of these things need to be included on the bridge. You need to have the phone, and then of course we need to make a phone list because it's not integrated in any way. And then you have a note here, and then you have notes about the blind sectors put on the radar, and you have lots of extra information notes around that are not necessarily embedded in the system because it wasn't designed as a holistic workspace. It was this supplier must supply this panel with these things on it. And then you as a seafarer need to learn where all of those things are, and you need to remember where they are, remember what the context is, and then try to use it operationally in your work. And like Margareta had said, that there was a lot of missed cues that happened that resulted in accidents. And it's not because the seafarer is not good, it's just that maybe that cue was only here on this one screen and you had an alarm coming off on the other side of the bridge at maybe the central panel, and maybe you didn't see. So there's a lot of reasons why these things can happen, and I think that a lot of them have to do with the fact that bridge systems and even other control room systems as a whole aren't designed to meet the user's goals. They're designed to meet a list of requirements. So they meet one, but they don't meet the other. So that's something we can talk about some more. I think we can go into this. So as you saw in the video at the very beginning, there's something that we're working on in the Ocean project, which we're really glad to have the partners that we have in this project, both from HVL, like Margareta and Erik, and from the Nautical Institute, and my entire team of designers who are really amazing at what they do. We're trying to build this 4-dimensional situational awareness display. So if we were to have a system on the bridge that could combine information from all of the other systems and present it in a way that could enhance the situational awareness both now and into future timelines, so 4 dimensionals being the 3 dimensions in which the ship is navigating, and the 4th dimension of time added in, where we could enhance the situational awareness to prevent collisions and groundings and elisions and container strikes and whale strikes, and explore these situational awareness problems that currently exist because of miscues or other items, where we could proactively increase situational awareness and make sure that it's helpful and trustworthy and eases decision-making and bridge team management, which I think is easy to say and very difficult to do because there are many different types of bridge teams. There are many different, levels of training that you have. A lot of the seafarers that we've interviewed so far for the project happen to be operating in the North Sea and happen to be European and educated in Europe. And the mass majority of seafarers are not necessarily those people. And when we're looking at the 30,000 ships that we deliver to as Kongsberg, we have to look at all of the different seafarers. And in order to do that, we need to have participation from them. During the project, we looked at so far the different goals that mariners have in operating a vessel and the goals that they have for situational awareness. So the highest level goal that you have as a navigator on a ship is safe operation and navigation of the vessel. You want the vessel to navigate safely, you want to be efficient, you want it to have safe operations, everyone goes home, no problems, smooth seas, right? And to support that goal, you have kind of mid-level goals. And mid-level goals change depending on the context. So you have safe operation and action in a crisis. So if you have a fire on board, if you have piracy, if you have other things happening that require immediate action and immediate awareness, it's a different type of system that you would need to fulfill your goals. Versus what we're talking about with the situational awareness display is this tactical situational awareness. What do you need to know now and about the near future to make good tactical decisions? So dealing with traffic, dealing with no-go areas, dealing with survey vessels crossing your route, dealing with different things that you see outside, or changes in planning, like the port will tell you to go to a different buoy to pick up the pilot, for example. Those kind of tactical situations where you're planning for the next 12 minutes, the next half hour, the next hour, versus overall long-term planning, like doing the passage plan and setting up the full voyage plan with all of its notes and all of its reporting points and all of the statutory requirements that you have for doing kind of long-term planning of the vessel. And so we're not looking at this crisis scenario for the display that we're making now. And we're also not looking at this long-term planning scenario, because I feel that in creating a good bridge working environment, these actually require different systems. It shouldn't be the same system that you're using for long-term planning that you use to make tactical short-term decisions. And that also shouldn't be the same system for using during a crisis, because most of the time you won't need all of this information in one place. So the way we're approaching it is only looking at this situational tactical awareness display for this project. And in that, we have some lower level goals, which we have a really kind of interesting question. And I don't know if David, you can put that up now, on which kind of tasks they have prioritized.
Yep, hold on.
Yep.
Okay, what two tasks, so you can choose two here, do you spend the most time on to build your situational awareness at sea? So Jackie, maybe you can elaborate on that a little bit as people are doing the poll.
Yeah, I lost you behind my slide, but hopefully I can still see you. So the different kind of goals that we have here is understanding where your vessel is now and in the future. Do you spend the most time on that? Do you spend the most time trying to understand the behavior of other vessels in your surroundings? You spend a lot of time on radar and AIS and trying to figure out what ports that vessel might be going to, what route they might take. Are they going to turn or they're not going to turn? Do you spend time trying to understand the relative position of non-moving objects that are around you, like no-go areas, non-moving objects like buoys or lighthouses or spars or quays? And then do you spend a lot of time trying to make sure that you're staying within the vessel's operational capabilities? So not changing speed, for example, or making sure that you have enough power, or if you need to use thrusters, how much thrusters are you going to use? How do you keep within those operational limits is another one.
Okay, Jackie, so the answers are in. Can you see that?
No, I can't see that. Let me.
Okay, I'll just review it briefly. The assessing other vessels' behavior is clearly the forerunner at 81%, followed slightly by knowing the vessel's current and future positioning at 54%, and then keeping vessels in a safe navigation area at 43%. And folks, I'll just remind you that this is really important to us, and we've recorded that and we will use it in our development. Back to you, Jackie.
Yeah, so what we did with this goals was actually part of one of the deliveries that you can already see. If you're on the Ocean website, you can read, if you're really interested, a 90-page document on different navigational contexts that we looked at and how they're handled, and what goals we found doing that research, because I had my design team on board vessels with one of our other partners to observe bridge teams in action for several days. So that's how these goals came about. I didn't just pull them out of my pocket, but it's something to think about. So if you're interested, I think it's called D7.1 and it's on the Ocean website. So if you're really interested, that's download and public, so you can look at that. When we are designing these kind of displays, we came up with some hypotheses of things that we think might solve for some of these challenges that we found both during the observations and that came out of the work package that happened before in the project that was focused on the accidents and the causes of maritime accidents. And my team, how we work with mariners is sometimes when we're lucky, we get them in the office and we can do these kind of paper sketches. So we take some things that are elements from design systems and some things that are pen and paper, and we try to work out how might we visualize this in a good way? How might we approach this problem? What kinds of displays because we have a lot of options right now. We can use camera overlays, we can use augmented reality, we can use active screens, we can use radar formats. There's a lot of ways that we could visualize this information, but what way is best? So we have mariners come in and we test things and we try things and we ask questions and we listen to stories. And through that kind of contextual development, we find out that, oh, well, maybe actually it's interesting to have a target trend on, is the target changing heading? Is it changing speed? Is it changing CPA against us? How fast is that changing? And that was brought up from the user test because I'd never seen a target trend before, and I think that most mariners haven't, but it's really an interesting question because when you're looking out the window, you're looking for aspect of the vessel to change. And looking at the trends, you're also seeing the aspect change. So the goal is to have the systems do as much work as possible for the mariner and not necessarily have the mariner try to do all of the work in their heads to build up the picture of what's happening around them. So that's kind of what I wanted to share, and I guess we can kind of get into discussions with both Margareta and David. Don't know how to stop sharing my screen, but we can go through the pictures if you're interested. But yeah, that's kind of it.
Thanks very much, Jackie. That was brilliant. You know, just for you, the younger viewers, just to realize that Jackie's job does exist. There are people who take this thing very seriously. So just looking at some of the questions that are coming in, given the bit of time we have left, Mustafa has asked, and Margareta, I'll go to you first on this, has asked about why don't we just copy what aviation does? Because surely they're better at this than we are, particularly in terms of alarms.
Yes, we could copy what aviation does, but then aviation has something like 3 or 4 major manufacturers, whereas shipping has something in excess of 30 different brands, manufacturers, and companies making our systems for us. So not saying that we should reduce the number of manufacturers, but we need to find a way to standardize across. And also there are major differences in our domains that make it less easy to just import wholesale. And I do believe we have imported some things, perhaps unthinkingly, but we've also imported things that do work for us, like the co-pilot system. So I think we should definitely look at other domains, but think about whether it fits us before we just grab it.
Okay, thank you very much, Margareta. And we have Erik who's joined us. Thank you very much, sir. And in fact, I'm very glad you did, because the next question's coming to you, and I didn't want to be the one that answered it. So this is from Peter. And he says, well, this is clearly aimed to improve real-time operational decision-making. How will it be viewed by the IMO? And is it intended to become part of SOLAS or be used for in the call regs?
I'm sorry, first of all, I'm probably in a very noisy environment, but I will try to answer in any case. Hope you can hear me.
Yeah.
We are on purpose, and I'm looking at Jackie when I say we are on purpose going beyond SOLAS. We are on purpose going beyond regulation because we want total freedom in experimenting with this. The only two things that we know that we have to fulfill to make it real life is IEC 62288 and IEC 60945, which makes it suitable for bridge operation. But this is beyond type approval. This is beyond the performance standards. The hope, of course, is that if this works, if we can demonstrate that it works, if we have the mariners telling the world this works, it might influence the IMO. But that's a dream, that's a hope.
Okay, thank you very much, Erik.
Just to say, I agree with
Yeah.
Erik there. I think that it's really important to go beyond the current regulatory standpoint, because right now we're back in the late 90s. You have a Walkman full of CDs, you have a big old brick phone, you have a camera separate, you have all of these separate pieces of equipment that you're carrying around to go on your super hiking trip, where you have a bunch of extra battery packs, you have a pager because you can't send text messages, just crazy amount of equipment that's all disconnected. And then you have to pick out which piece of equipment you want to use for which purpose, instead of having all the data there at your fingertips like you have now with your cell phone. And we haven't made that transition in maritime. And in aviation, they kind of have made that transition, because their navigation suite is all made by one company and all integrated. And on the ship's side, it's not. You have all of these pieces of equipment that might be connected and sharing information, but you still have that primary equipment source where you have, I use radar for this, I use ECDIS for this, I use the VHF for that, I use NavTex for this, I use the GMDSS for that. And you don't have that full integration outside of your own head. So you're relying on yourself as a mariner to make sure that you've scanned all the possible information categories and you've taken it in your mind, and you have that picture in your mind of what's going on. And your shipmate in bridge resource management also has that picture that they've made themselves, and you might not have the same picture. And being able to discover that you have different pictures is one of the key challenges there, which is why communication is such a big part of resource management. And also one of the biggest challenges that we have as an industry. And it's because everything is so separate, in my view anyway.
Jackie. We've got a question here from Mohammed, who is asking what's the difference between the flow of the information and what we've heard about ergonomics, the placement, where you put the equipment on the bridge. So while you're answering that question, I'm just going to do another pop-up poll that's going to ask, do you want to be involved in this project? We've had a lot of questions. Time is limited. So if you say yes to this, you will be contacted by the Ocean Project. So ergonomics, Jackie.
Yeah, so ergonomics falls into part of this human-centered design, where we're making sure that it's fit for purpose. And in you're talking about the readability, you're talking about the physical comfort, you're talking about the console heights, and ergonomics covers part of it, but there isn't a standard regulation for all of the ergonomics on the bridge. Each manufacturer is kind of left to do it on their own. And when they do that, it's not necessarily ergonomically tested between the manufacturers of using this and this and this and this. We'll say that, okay, the radar screen must be this size and it must be placed in a console of this height. And at that height, we have a calculated reading distance of this far. And that reading distance goes with the font size. And when it's actually installed, there's not necessarily a verification of whether or not it's installed in exactly that way. So I think the ergonomics challenge is also similar to the data challenge. I don't know if Erik agrees with me on that, but
no, I think I would like to add to it. I mean, what we see on modern bridges is what is popularly called Radio Shack integration. So the idea is, if you put a lot of equipment close to each other, then it's integrated, and that is not the case, because integration is much deeper and means that you have consistent data, you have consistent operating paradigm, you have a right mouse click means the same across all your systems, etc. So this is where it becomes complicated, and this is where the tradition in maritime, where instruments are type approved as individual instruments, becomes sort of an issue, because they fulfill all the rules and regulations, but they are not necessarily the same. and the operating philosophy is in most cases not the same, and that poses a challenge to the mariners that we somehow have to address or need to address or should think about.
And David, can we run the last question before we?
Yep.
Even though we're getting tight on time, I think.
We
I'm not sure anymore.
By the way, on the last poll, the majority of people did want to get involved, Jackie. So.
Oh, perfect. So this question is about the displays. Is we had these hypotheses of things that we think you might want in a situational awareness display. So pick 3 that you like, and then we can always discuss in the user testing, because these are things that are undergoing user testing at the moment. But we had some feedback that a head up for improved visual surroundings visualization could be interesting, like the picture that I showed in the last picture I showed with the visual on the top. Trial maneuver to project scenarios from known data. That includes, the data about tides and currents and movement of floating objects with the tides or movement of traffic. Synchronized targeting across visual AIS and radar. So if you have a camera system that's identifying visual targets and AIS targets and radar targets, and maybe some things that are given to you from VTS, would you want to see that? Would you want to see the cross-check of errors across these data sources? So if you had multiple targeting, how offset are they? What's the agreement or disagreement among the data? Or would you like to see more emphasis on no-go areas and caution areas and safe area checks, and how that might be shown in a different way than how ECDIS shows it? And that's this question in a nutshell, I guess.
Okay, thanks very much, Jackie. There's a fairly good spread there, but I'll share that with you for your research in due time. We are just about overdue, so if you'd like to learn more about the Ocean Project, go to the website. If you weren't quick enough to vote yes on becoming involved, there is another opportunity to say yes in the post-webinar poll, so please feel free to do that, and we will be in touch. And finally, of course, we are the Nautical Institute. We are a membership organization, and we welcome you to become a member if you're not already. And just out of curiosity, there was a question, why is the Nautical Institute involved in this project? And the reason is that we were approached, and Erik clearly stated, this is a project that understands that mariners make good decisions. We want to keep mariners in the loop. This is not about automation. This is about helping mariners make better decisions, and that's why we joined. So thank you very much. Jaquelyn and Margareta, thank you for your participation and all your wisdom. Erik has disappeared. Thank everybody who has joined us very much for your participation. And if you have said yes, you'd like to be involved, we will be in touch with each and every one of you. Thank you very much. Goodbye, folks.